Good day everyone, and I have to share to you, what is a general or non-concurrent force system and its resultant. Okay, let's start with the definition, A general or non-concurrent force system is consisting forces acting in any direction without a common point of intersection. So when this is unbalanced, or that would mean if it has a resultant not equal to zero, the effect of that into the body is to create motion. And the motion is a combination of translation and a rotation. So it may move along an axis and it will also produce rotation as a moment effect. Okay? Now, the magnitude of the resultant, so just the same, we can make use of the component of the system of forces. So we can have the summation of forces along X, along Y, and to find the magnitude of your R, then you can have the square root of the sum of the squares of the component of X and Y. Component of R along X and Y. The summation of forces along X is the Rx. The summation of forces along Y is your Ry. Okay, there you can obtain the magnitude of the resultant. Now, for the direction angle, and if the angle will be expressed in standard position, then we also have to start with the reference angle. By formula, the summation of forces along Y divided by the summation of forces along X. If we take arc tangent of the absolute value of that ratio, then that will give you the reference angle. To recall, reference angle is a positive angle measured from the nearest x-axis to the line of action of your R. So we have the magnitude, we have the direction, and we can also go with the location. So location is obtained by Varignon's theorem or applying the moment principle. So if there is a body acted by forces, so there we have the moment produced by the R when we multiply with R and the moment arm. So if my E is the point or the moment center, then I can have the moment arm, which is the perpendicular distance of R. Then these forces will also produce moment, and the sum of the moments produced by the components of your R is actually equal to the moment produced by the resultant. By the way, if you notice, F1 and D1, if this is my F1, so dapat there must be a distance, a perpendicular distance to A. But that is if, panalitan I have an F2, that is if I know the distance of F2 to A. But if in case we do not know the distance, then that's the time we can reduce this in terms of components. Okay, so the same, previously on the previous problem. Now, determine the magnitude, direction, and location of the resultant for the applied forces. Okay, so given a body acted by several forces, So if these forces will intersect, they will intersect not at the common point because this is a non-concurrent or a general force system. Now, how to get the magnitude of the resultant? I have to start with the components, by taking the summation of forces, horizontal and the vertical. Now again, I tried to redraw my figure because one of the forces, so there is no angle defined, but I have to make use of the dimension where I can possibly make use of this. This is 10 and this is 8, but since your 10 and 8 has a common factor 2, so I can reduce the side of my triangle, or I can make use of a triangle which is a similar to a triangle formed with side or legs of 8 and 10. If I'm going to remove by dividing to every dimension of sides of my triangle, then I can produce 5 and 4. So instead of using 10 and 8, then I can also use maybe 5 and 4. Okay? So this triangle is just similar to the bigger triangle. Okay? So if I have to take the summation of forces along X, so 60 is exactly acting horizontally. To the right, that is why it is plus. If I have 200 here, so it is directed to the left. So the horizontal component is also acting to the left. That is why it's negative. It is adjacent to 70, so I can have the cosine of 70 multiplied to the magnitude of my force here. Then another force is 100. If that's 100, the horizontal component of that is parallel to the horizontal side of my triangle. So I can have 4 over the square root of 41. Actually, 41 is taken from the hypotenuse of this triangle. Square of 4 is 16 and the square of 5 is 25. So 16 plus 25, that's why I obtain a sum of 41. So I take the square root following the Pythagorean theorem. So it's 4 over the square root of 41. So there being no other horizontal or forces having horizontal component, because this one is exactly vertical, so only these three forces bears components which are horizontal. Okay, so taking the sum, I obtain a value which is negative. That would mean the effect of the forces is to the left. Okay? Now, how about the summation of forces along Y? So, 200, so I'm referring to this, no? So, my 200 force is acting upward. That is why the component of which is also going upward. That force is opposite to or similar to a force that is opposite to 70, then I make use the sign of 70. 300 is actually acting downward. That is why the sign of which is negative. My 100 is directed down, so it is also having a component which is directed downward. So it's negative because it's downward. Now, for reducing the force into components, so the component is parallel to 5, so it would be 5 over the square root of 41. Now, taking the sum, I obtain a value which is negative. So, both are negative. If x is negative, or the component along x is negative, so that is directed going where? Left. Yeah, this is directed going down. That would mean that your R is acting at what location? If I have to consider the quadrant, so that would be in quadrant number 3. So, finding the value of your R for the magnitude, so I just follow the formula. No? And I have values to be substituted here, then I can obtain the value. Now, being in quadrant number 3, so the approximate position of your R will be like this because that is in quadrant number 3. Or say, it would be like this. No? So, this is your R. Then I can possibly solve for an angle formed from the nearest x to the line of action of your R. That angle is what is termed as the reference angle. Now, to get the direction or the angle in standard position, so I can start with the positive x counterclockwise, and this is your positive angle. So you can have this, which is actually the sum of 180 plus this value. But for the negative angle or clockwise angle, which is this one, so obviously this is 180 minus this value. H is this angle here. But if this is plus, this angle must be negative considering the direction of the angle. Okay? Now, let us solve the value of the angle. So, for the direction angle, so here I have the reference angle. Basta never interchange the ratio. This is summation of forces along Y and summation of forces along X to get the reference angle. Because if that is summation of forces along X then over summation of forces along Y, then what you solve is the reference angle, which is this one. It is an angle from the nearest Y to the, which is to the line of action of the force, which is actually a complementary angle to your reference angle. Okay, so that is if mag-interchange imuhang ratio. Okay? How about the value of your theta? For the direction of R, or obtaining the value of theta, if R is directed going left downward at an angle of, so we can describe as this. If you are not required to give the angle in standard position, so you can simply describe. So, R is directed left downward at an angle of 69.558 from the horizontal axis. But, as angle in standard position, then I can have my theta. The theta here is the one which is the positive angle counterclockwise. So there I have 180 plus the reference angle. We know that the reference angle it has a value of 69.558. So adding the two, there I obtain this result. Now for the angle which is produced through a clockwise rotation, which is this one. So just consider that I have 180 here. 180 subtracted with the reference angle is this one, no? Then I put a sign of negative to consider the direction or the rotation of your angle. So there I obtain negative 110.442. Then next is the location of your R. Okay, so we already know the position of our R, that is from a point directed to the left in a downward manner or direction. Then this is now my approximate position of my R. Now, if I'm going to consider the distance of my R to any point of reference, just for example, from point A. Now, I just assume that this distance is a perpendicular distance, and this will serve as a moment arm. So, distance from A, or maybe I can use other point like C or any other point you like. Now, so, then assume that this is also a perpendicular distance. Okay, and this is DC. Okay, now assuming that I'll be using the point A as my reference. So, distance of R from A, which is the DA in your figure. So, the moment will be taken at A, or A will be used as a moment center. Okay. What is the rotation? Okay. Para you won't be confused of the sign of your moment, no? With respect to a point or a moment center, just try to hold a body at a certain location, then apply the forces. Now, by the way, what is the advantage of using A as my reference point? The advantage there is that there are several forces wherein these forces will pass through a point A. And if that is the case, like this one, this is inclined. So, if that's the case, then I can eliminate the effect of this, no? As to moment effect, no? Okay, this will not produce any moment. So, two forces can be eliminated in your moment equation. So, do not include this anymore. That is why it's good to use A. Okay, anyway, later I have to use other point for comparison. That is if there is no point mentioned which will be used as a reference point. In this case, I just consider my A being my moment center. Okay, as my reference point. Now, so, the haka forces mag-agi diha. So, this force will no longer appear in the moment equation. Okay? The moment produced by your R, if you hold a body at A, or maybe at tip of this, can this be seen, no? If I have a body wherein I have to hold at this end and apply a force somewhere here, the force R is a diagonal force. So, if my force is diagonal, then it will tend to let the body be rotated in a clockwise manner. Clockwise rotation is positive, as we assumed previously. So, we have R times the dA. My R has a value. This is the value of your R. Now, so, we substitute the value R with D, and that's equal to, so then, consider other forces. If 300 is considered, so 300 has the same moment effect or rotation, no? So, which is clockwise, no? With respect to A, then the body will rotate that way. So, it has the same sign with the moment produced by your R. So, what's the distance? If this is 300 force, so it has a distance of 14. Okay, so 14 multiplied to 300. Now, this one, 200 is this one. So, it has vertical component, it has horizontal component, but it's good because the horizontal component has line of action also passing through A. So, 200 with the vertical is opposite to 70. I'm using sign of 70. The total distance here is 20. Okay, so just take the sum, and I have my dA. It comes out to be plus, and what is the significance of the positive sign? That means that this is the correct direction of your, or location of your R with respect to A. Okay? So, what if I'm going to transfer to another point as my point of reference? So I'm using C, and I have to solve for the DC. Take moment C or moment at C, so C will be used as the moments in there. Now, if C is somewhere here, now naadiri ang C, you just hold your C here, and then your force, your R, is here, so that will tend to let the body be rotated, so man, counterclockwise. So if that's counterclockwise, then I can have a negative, negative of R, negative of the product of R and DC. This is my R. That's why it's negative, because the effect of which is counterclockwise. Other forces, so if I'm taking C as my moment center, so only this force is out together. So daghan di, no? This one and this horizontal. So will also, or the force acting horizontally will also pass through here. So these two forces will no longer appear, including the horizontal component here. So if I have this one, the two other forces is 200 vertical component. What is the effect when you hold the body at C? The effect of which, no, is to produce a, what rotation? Counterclockwise rotation. That's why it's negative. Sine of 70, then the distance is 6, which is this one. And if I have the vertical component, vertical or horizontal? If I have the horizontal component, this one, this is 4 over square root of 41. 4 is horizontal, so this is a horizontal component of 100. So 100 times 4 over square root of 41, then the distance of this, kine, naman rin mong horizontal, no? So 10 is actually the distance, perpendicular distance to C. So I'm using 10 for the distance of the horizontal component here. Vertical component is parallel to 5. That is why we have 5 over square root of 41, and the rotation is still counterclockwise. Counterclockwise because your force is there, paubos, no? You are holding somewhere here, and if the force is going there, so counterclockwise. Ganina, the horizontal component, as if you have a body, no? Having a distance pa dire, this is your C, and then the force is above the body, so same mo yan. So munang mo rotate siya in a counterclockwise. So these are all negative. But if these are all negative, the sum of which is negative, but we also have a coefficient negative. That is why DC comes out to be positive. So this is now the position of your body that is in between AC. Just in case sa DA ganina ni gawas nga negative, so most probably the resultant can be found on the opposite side. So it can be found there. Okay? So just for example, your DC is negative, so it can be found somewhere here. Okay? So that is how you interpret the result as to sign of the distances, whether it is positive or negative. Now, when you solve problem, no, always reflect your R. No? Never solve or use a moment equation without reflecting your R in your figure. Because putting your R in the figure help you determine the rotation of the force or the body when it is acted by the force. Now, again, you're asked to give the magnitude, direction, and location, but this time, this is different because there is a specific point of reference. So, usara itong solbon, it is only the location of the resultant from a specific location A. Okay? This is the body acted upon by forces. No? A right triangular body. Forces are acting upward. Doon ay horizontal at the distance of 2 centimeters. So this is 6 centimeters. All in all, this is it. This is 6 centimeters. And at a distance of 3 centimeters, there is a force perpendicular to the hypotenuse. That is 50 Newton. At the other vertex, so there is 20 Newton acting horizontally. Question is, what is the magnitude of your resultant? That refers to the value of R. So using the analytical method again, I'll have to use the different components. I have to take the summation of forces along X, along Y. Okay, so we have the value or C. Now, I tried to retrace now because in taking the summation of forces vertical and horizontal, so this is inclined. So I need the vertical component, I need the horizontal component. To easily analyze my figure, if I'm going to reflect, because these are not exactly part of the given and this is not, this is already part of your analysis. To visualize, I put an angle theta, a base angle of my triangle here, which is dire. So, I inserted an angle. Now, if I'm going to draw a line, dire, exactly vertical because the component will be taken along this vertical line, no? Then this angle theta is actually because there is a triangle form, a right triangle, wherein this is 90, this is theta. Kini, this is complementary to that angle. That means 90 degrees minus theta because their sum must be 90. This two angle dire also has a sum of 90. So if this is 90 degrees minus theta, then this would be theta. Like for example, you have 20 here. This is 90, then this measures 70. So if this is 70, that follows that the angle here will also be the same measure here, which is 20. If I say this is 20, then this is 20. So two intersecting lines, the alternate angle must bear the same measure. If this is theta, then theta can also be found there. So I was able to define an angle inside your right triangle using the components of the first 50. So vertical component, horizontal component. Okay. Now, before I proceed, instead of solving for the angle, I may just define a ratio of sine function and a cosine function because they are actually needed in taking the vertical and horizontal component. The sine theta from this figure is it. This is it. It over the hypotenuse. Say this is it, this is 6. So if you solve for the hypotenuse, what's the result? 8 squared plus 6 squared. Their sum is 100. Square root, that is why there is a value 10. 8 over 10. 8 over 10 is a reducible ratio which can be 4 over 5. That is why when you have a triangle having a side where there is a common factor 2, so you can reduce that in terms of another triangle where the side is smaller compared to the original. So I have 4 and 5. So if I have 4 and 5, that is a similar triangle. So it's either you have to use 8 over 10 or 4 over 5. But if you're dealing with a smaller value, then it would be easier to come up with the same, would be easier to perform some operations. So that's why it would be good to use 4 over 5. But there's nothing wrong if you use 8 over 10. The cosine theta. The cosine of the angle theta is adjacent side. So it is 6 over the hypotenuse, where we know that this is 10. So 6 over 10 can also be reduced to 3/5. Now, taking the summation of forces, okay, I have y here, so vertical component, one of which is 55, that's upward. Then there is another force coming from the inclined force 50. And we have 50 downward, di ba? And that is adjacent to the angle here. So I can use cosine theta. Okay? So the cosine theta, there's a value here. Let us see how this value is obtained. The cosine theta is actually can be replaced with a value here which is 3/5. No? So if this is 3/5, that is 55 minus 50 times 3/5. That is why I obtain 25. So gawin ng 25 ganina, no? So bright siya. Okay, bawa na siya ng 25. This is still a value which is not substituted yet. Okay, that's 25 and that is how it is obtained. The summation of forces along X. Okay? So I have 30 going left. No, that's 30. Negative. I have 20 going left. That's also negative. But the horizontal component here, because my arrow is here, so it is directed to the right. That is why it's plus. Opposite, so I'm using sign. So the value of sign can be replaced with 4/5. So if that is replaced with 4/5, there I have the minus 10. Your R can easily be obtained using the formula, taking their squares, the sum of their squares, so I take the square root, there I obtain the magnitude of R. So I already have the magnitude, and next is the direction. Direction, okay. So by the way out from this result, this one. If my y is plus, component along y is plus, so it's directed upward. This is negative. So y is positive, then x is negative. So that is a force found in what quadrant? I think nasa sa quadrant number 2. Correct? Okay. Now, reference angle. Take note that our R is in quadrant 2. We are solving for the reference angle, a ratio between this one and that one. I obtain this one. That's the reference angle. When plotted, the R is now shown at quadrant number 2. This is the angle you solve with 68.119. How to find this? Very familiar. That's 180 minus this value. So I can obtain this one. And that is the magnitude. That's the direction that is required. Direction which is an angle in standard position. If you like to determine the negative angle, sorry ka mag-agi. 180 plus this value, and you assign a negative sign if you like. Okay, so we have a negative 248.199. And then we can bring this one. You can put this into your figure, reflect that into your figure, and take the distance to A. Okay, to solve for the location. Okay, there you have the location. They have the figure, and I reflected my R that way. This is my DA, where we need to solve. What is the location of your R from A? Okay? So, again, those are the sine and cosine values we needed. Okay, what is the location from A? DA, I take moment at A. So, A is my moment center. What is the rotation? If you hold your A, okay, or a body where you hold somewhere at the point A, and the direction of your R, no? You pose your body that way. So, the body will be rotated. What manner? What manner? Counterclockwise. So, counter, munang negative is the sign. This is your R value. Then you have the DA, this one. That is the rotation or moment produced by your R with respect to A. Now, components will also produce rotation. Say, my 50, even though it has component, pero I don't need this distance anymore. I don't need the distance here down because I already have a perpendicular distance of 3. So, I can make use of 3 directly without reducing 50 to component. But, what is the rotation offered by your 50 Newton force? If you hold her and you pose the body there, then the body will be rotated in a manner which is clockwise. No? Mo clockwise yan. Unlike ganina sa R nga mo, counter. So, this is now plus 50 times 3. Okay. How about kining minus 30? This one. The minus 30 as you pose the body there, holding her. So, and rotate about this point, then the distance is 2. And that is counterclockwise. 30 times 2. I also have it here distance, and my force is 20. That distance of it is maintained, So, that's a perpendicular distance. So, 20 times it. Negative because it's counterclockwise. 55, this one. You pose the body up. So, the body will rotate also counterclockwise. 55 with a distance 6. So, you have 14.86 centimeters distance, perpendicular distance to A. That is the location of your R from A. Okay? So, that is the non-concurrent or general force system. The effect of the unbalanced force. It is termed as unbalanced force when there is a value of R. Because when the forces acting on the body is balanced, it would mean that the resultant is 0. If the resultant is 0, then it will not cause movement, no? Walay rotation, o wala say translation or movement of the body along an axis. Okay? So, thank you and I hope everything is clear to you. Okay? So, good luck. Bye-bye.